So I'll go into a little bit more detail on the M&E and modeling implications of the well building standard. I don't know whether any of you have already modeled a building that's trying to achieve both BREEAM and LEED, but at the moment, unfortunately, it's sort of as painful as that. But there is quite a lot of adaptation going between obviously a lot of the standards that come from the US at the moment and what may be applicable in the UK. I think the fact that it's a standard that applies to occupied buildings more, so there's a core and shell version, but there's definitely more interest from occupiers, means that it's applied in fit-out projects which have shorter programs, so there's a much bigger drive, I think, to quickly adapt well into UK contexts. So Anne-Marie gave you an overview of all the sections. There's 104 features in the well building standards, and about half of them are M&E related, particularly when you look at the mandatory ones, which are essentially what is required to even get silver certification. No surprise, most of the MEP implications are in the air, water, and light and comfort categories, but there's also quite a lot in the mind section. None in nourishment, so you don't yet have to advise on food, just in case you are worried. I'll skip quickly over these because Anne-Marie has given an overview, but whether you're a modeler or dealing with your MEP colleagues, the main sections that you'll have to look at are air in terms of ventilation rates, ventilation strategies, filtration, potentially extract at source. Water quality, as Anne-Marie has mentioned, essentially testing what's already on site. There are quite strong standards in the EU and in the UK on water quality, but CIBSE themselves, in their guidance, say that 20% of UK buildings don't meet the UK standards for lead levels. So it's not just a passing comment on that old Victorian house, for example 9, which doesn't meet the lead levels. You can check it online. It's actually quite significant, and maybe we should just by default do these water testings when we start a project. They're quite cheap as well. So, light, I'll come into more detail, but the three main areas it looks at really are promoting daylight and preventing glare, ensuring that there's enough light in the right space for us to see properly, and then the circadian lighting concepts that I'll come on to later, which is more about our alertness. I'm focusing on the office version. As Anne-Marie mentioned, there are versions that are for other uses, for example residential, and there the circadian lighting concepts are not only about making sure that we are alert and productive when we need to be, but also that we're not distracted by essentially blue lights in the evenings. Fitness, just be aware, there is one MEP implication, is that lighting may need to be a little bit at higher levels than what you would typically design for, so that it's not a dodgy back staircase, but actually something engaging that encourages people to take the stairs instead of the lifts. Comfort will come on to with quite a lot on thermal comfort as well as acoustics. And then in the mind section, as well as all the operational and HR issues, there's a suite of credits which are about user engagement and post-occupancy evaluation. I'll give more detail on that. So in the ventilation section, well, air, but there were credits with modeling implications potentially are essentially about ventilation rates and CO2 levels. This is a mandatory credit. I'm speaking BREEAM speak by saying mandatory credits. In WELL speak, it's a preconditioned feature, but I'm sure you're more familiar with BREEAM. So these credits are typically evidenced actually by just letters of assurance. So modeling isn't strictly required, but obviously you or your MEP colleagues, before they write these letters of assurance, might want to have done some calculations and modeling before you state something. And then on the humidity level requirements, there's also a measurement on site. a lot of the requirements in WELL are much lighter than BREEAM at the design stage in terms of evidence, which I'm sure you're all very happy about. But that's because there's much more emphasis on performance and testing on site, and not performance at PC before the contractor walks away, but performance when the building is actually occupied with a minimum of 50% occupancy and 6 weeks after occupation. In terms of evidence equivalence with UK standards, there's already one approved international equivalent, but roughly speaking, compared to, say, CIBSE guidance, the ventilation rates in most cases for open plan offices will actually be less onerous than what CIBSE and BCO require. Obviously, you need to check that space by space, and it depends on the densities, but it's not actually as onerous as you might fear at the start, particularly on a best practice office building. In CO2 levels, it's slightly more onerous than some of the guidance out there, but again, you're probably designing already to stay below these levels. In the comfort category, there is modeling requirements, and it refers to ASHRAE. So at the moment, there is no approved equivalent that I know of using CIBSE Guide A criteria, but the ASHRAE criteria actually take a similar approach to operative temperature and PMVs. So in theory, in terms of the approach, it might not necessarily lead you different paths, but they may at the moment be double modeling required. If any of you are working on an equivalent applications, let us know, because as soon as they're approved, everyone benefits. There's also additional credits, such as encouraging displacement ventilation for air quality, which has to be backed up by CFD, and encouraging radiant heating and cooling systems. As you can see, some of the credits come from an American background, so we wouldn't necessarily always feel in the UK that we have to do CFD to show that displacement ventilation systems work. But in the US, it's still a bit more innovative, and it needs more evidence. In the lighting side, so the three main areas that may need modeling. One is on lighting for visual acuity, so there it's very similar to what you would typically do in the UK. So it's lux levels at the working surface, and typically between 300 and 500 lux, so quite similar to CIBSE guidance. In daylight terms, it uses slightly different metrics, so daylight autonomy, as opposed to daylight factors, which we would usually use, although BREEAM actually does have an option to use essentially daylight autonomy. So it may be that you don't actually need to look at two metrics, and it would be good if IES could advise maybe in the discussion whether we can generate all this data with a single model. The big difference and the innovation is in the circadian lighting design. So it proposes a new metric, and the world building standard is quite open about the fact that it's a proposal and it's evolving, it's quite new, and that it may evolve as science and feedback increases. So it proposes a new metric that is not only weighted to how light affects our vision, i.e. lux levels, but also how much it affects our circadian cycle. So how effectively the effect it has on our alertness. And basically blue light, so if you were to design to the same traditional lux levels with something that is very, very blue, it will also be counted as having a high effect on our circadian lighting design. On the other hand, if you were to design with very warm lights, slightly unusual in an office, but it may happen, in that case it will be counted as quite inefficient in terms of our melanopic lux levels, and you would have to increase your lighting load. So there, modeling is not strictly required, but you're very much encouraged to actually do modeling so that you can take the account of daylight into your calculations and end up with the right melanopic lux levels, but not with excessive blue lights or excessive lighting loads. So as I said, most of the lux levels and daylight approaches actually broadly align already with SIBSI and the Society for Light and Lighting guidance.